All right, welcome back, everyone. Let's now continue the exercise from number 6, exercise 11E. Still on probability. Question 6 says, I'll go right to the page. M and N are the midpoints of opposite sides of square ABCD. A point is selected at random in the square. Find the probability that it lies in triangle ADM. I think that's straightforward, simple. If it lies in triangle ADM, that means it lies in this region painted blue. And if you inspect very well, that region is only a quarter of the whole square, because this is half, this is half, this is half. Can you see? You understand? This is one half here, this is another half here. So if it lies in this region, this region shaded here, it means it's only a quarter. It only lies in a quarter of the triangle. So probability that point is in triangle ADM is area of triangle ADM over area of the whole square. That's 1/4. Okay. B says find the probability that the point is in ADM but not in ADN. If the point is in ADM but not in ADN, let me clean this. If the point is inside ADM, that means it's in ADM, but it is not in ADN. It is not in ADN. So that means we are only talking about this small portion of ADM, because that's the only way the point can be inside ADM and not be inside ADN. That's the only way it can be in this triangle but not fall into this one. So that means we are referring to just this small portion of ADM. And if you look very well, this is just one portion out of 4 here. Let me change my color there. This is 1, 2, 3, 4 portions of half of the triangle. You understand? So this is just one portion out of 4. So if you look at the diagram very well, you will see this part is only 1/8 of the whole square, because there will be 4 portions here. There will be 4 portions like that here too. If we split this part too, we will have 4 portions too. 1, 2, 3, 4. 4 here too. 1, 2, 3, 4. So altogether there are 8 portions, and we're only talking about one section out of the 8 portions. So that tells you that the probability that the point is in ADM but not in ADN is what? Area of DMP over area of the whole square. This is DMP here. This is DMP here. Area of that portion over area of the whole square is 1/8. Question C says, if a point is selected at random, find the probability that it is neither in ADM nor in ADN. Not in ADM, not in ADN. So that means we are looking for probability that the point is not in ADM. That means it doesn't fall here. And it is not in what? And it is also not in ADN. This is ADN. And this is ADN. So I think we have marked out where it should not be. If it is not in any of these regions shaded, we know we have shaded 2 regions together, ADM and ADN. So if it is not in any of these 2 regions shaded, that means it is in any of these remaining area. That means it falls in this area. And if you look very well, this is just a quarter of the whole square. This is half of the whole square. You understand? Because there will be another 4 portions here. 1, 2, 3, 4. And this is another one. So that's 5/8 portions. 5 portions out of 8. So the area of this place, the area of this whole place now, will be 5/8 of the whole square. So area of that means it's in BN PMC, which is just 5/8 of the whole square. So Let me explain that again. I think I'm missing a point. The point I want to make here is that you can see this as just 3 portions. 1, 2, 3. And the whole remaining portion as 5 portions. So altogether there are 8 portions in the square. And this area will be, that of 5 portions. So if it falls in that region, that means the probability that it's in that region is 5/8. Question 7. Question 7 says a ball is dropped at random into one of 8 holes, numbered as shown in figure 11.12. The number under each hole gives the score obtained when the ball drops into that hole. Okay, state the probability of scoring 1. Okay. Probability of scoring 1. How many ones do you have here? 1, 2, 3, 4. How many 2s? 1, 2, 3, and 1, 3. So probability of scoring 1 is what? Probability of scoring 1 is number of required outcomes over number of possible outcomes. That's 4/8, which is 1/2. Exactly. Probability of scoring a total of 6. Probability of scoring a total of 6. Okay, if the ball is dropped twice, find the probability of scoring a total of 6, then a total of 4. Okay. If the ball is dropped twice, what's the probability of scoring a total of 6? I think we are going to need a table for that too. Okay, or we don't need a table for that. Let me check very well. Okay. The only way to score a total of 6 is to score 3 twice. 3 the first time, to score 3 the first time, and 3 the second time. The probability of scoring 3 the first time is 1/8. And probability of scoring 3 the second time too is 1/8. So that gives us 1/64. I think that's what we explained it. Okay, all right. Now, this is pretty simple. Because if you look at it, if you check very well, what are the possible ways of scoring a total of 6? It's only when you score 3 2 times that you get a total of 6. No other combination. 2, 3 will not give you 6. 2, 3 will not give you 6. 3, 2 will not give you 6. 1, 3, 1, 2 will not give you. And none of these results will give you a total of 6, except you score a 3 first time and you score a 3 second time too. That's the only way to get a 6. And the probability of doing that each time is 1/8. So that gives you 1/64. Okay, let us see. Find the probability of scoring a total of 4 if the ball is dropped twice. Now, there are many ways of scoring a total of 4. Look at it very well. There are many ways of scoring a total of 4. You can score a total of 4 by scoring 1 first time and 3 second time, or by scoring 3 first time and 1 second time, or by scoring 2 first time and 2 second time. So let's now combine this. If you score a probability of scoring a 1 first time is 4/8. Probability of scoring a 3 second time is also 1/8. So 4 first time and 3 second time. That's what 4/8 times 1/8. Also, probability of scoring, let me remove that. Probability of scoring a 3 first time is 1/8. And the probability of scoring a 1 second time is 4/8. So compute that also. Or, all of these are or. We could get 4 this way, or this way, or else this way. That's probability of, we could get a total of 4 by scoring 2 both times. So what's the probability of scoring a 2 first time? That's 3/8. Probability of scoring a 2 second time is also 3/8. Look very well. Number of required over number of possible outcomes. How many 2s do we have? We have 3 2s. And we have 8 outcomes altogether. So you add, get the answer for each bracket, add, and you get your answer. Here says, this one is about a race. It says, to select an athlete's team, 100 students were each timed over 1,500 meters. The data obtained is given in table 11.10. A student is chosen at random. What's the probability that the student's time was inside 5 minutes? Inside 5 minutes means less than or equal to 5 minutes. Exactly. So that's 7 plus 28 plus 65 over 100. So the number of students that did the race, what? 100. So number of those who were inside 5 minutes. Number of those who did the race or ran the race was 100. Number of students who finished, on or before 5 minutes is 65. So that's number of required outcomes over number of possible outcomes. You get 65 over 100. That gives you 13 over 20. Okay, find the probability that the student's time is less than 4 minutes. The student's time is less than 4 minutes 30 seconds, but inside 5 minutes 30 seconds. Okay, so how many students finished? Okay, a student is chosen at random from those whose time was inside 5 minutes 30 seconds. Find the probability that the student took less than 4 minutes 30 seconds. So how many students were inside 5 minutes 30 seconds? That's 88. 88 students finished inside 5 minutes 30 seconds. Can you see that? 88 students finished inside 5 minutes 30 seconds. So our total number of possible outcomes in this case is now 88. But of those 88, our question now says we should find the probability that the student chosen took less than 4 minutes 30 seconds. So that will be 28 over what? 88. That will be 28 over 88, which is 7 over 22. Okay, C. Find the probability. Two students are chosen at random. Find the probability that both took 5 minutes 30 seconds or more. Okay. Find the probability that both took 5 minutes 30 seconds or more. Okay. These are the students who took 5 minutes 30 seconds or more. These ones. The students here. The students between these, two ranges. So the students who took 5 minutes 30 seconds or more are the students in this range. Let's just put it that way. I think that's the correct way to interpret it. Yeah, the students who finished in this range. So the students in that range will be 100 minus 88. 100 minus 88 students finished in 5 minutes 30 seconds or more time. So that's what? 12 over 100 times 12 over 100. Okay, this will be probability that the first student chosen finished in that time and the second student also finished in that time. You understand? Probability that both finish in that time is the probability that the first one finished in that time and the second one also finished in that time. So that's 12 over 100 times 12 over 100. Okay, so the interpretation of that probability is that took 5 minutes 30 seconds or more will be those that finished at exactly 5 minutes 30 seconds or higher than that. So you subtract 88 from 12 to get the number of students in that range. Question 9 says the probability of a seed germinating is 1 over 3. That's success. Germination is success in this case. So that means probability of the seed not germinating will be 1 minus probability that it germinates. And 1 minus 1 over 3 will give you 2 over 3. If 3 seeds are planted, what is the probability that none germinate? Okay, that's a simple question. Okay, so germinate we have represented with G. The event that a seed germinates, we've represented it with G. We've represented the event that a seed does not germinate with G prime. So if this one is 1 over 3, that's success. This will be 1 minus 1 over 3. This is like failure. This is like success. So, P, probability of success plus probability of failure is always 1. So probability of failure is 1 minus probability of success. That's what we've done here. That gives you 2 over 3. The question now says, if 3 seeds are planted, what is the probability that none germinate? Oh, what a mistake. I actually did the probability that all germinated. So this should have been, let's correct it. This should have been G prime times G prime times G prime, meaning the first germinate, the first does not germinate, the second does not germinate, and the third one picked to does not germinate. So I'm actually going to correct this. It's not correct. This is not correct. So that gives us what? What's the probability that the first seed chosen or the first seed planted does not germinate? 2 over 3. And the second one planted does not germinate? 2 over 3. And the third one too does not germinate? 2 over 3. That's 8 over 27. Okay, I think when I check then. I saw that mistake too. Okay. Second question says, what is the probability that at least one will germinate? Probability that at least one will germinate. At least one is the same thing as not smaller than 1. So that means we are looking for probability that either 1 germinates or 2 germinate or all 3 seeds germinate. You understand? So that's probability that all 3 seeds germinate or only 1 germinate or only 2 germinate. So probability that all 3 seeds germinate, that's at least 1. At least 1 means 1, 2, or all 3 seeds. Is that clear? Not 0. At least 1 means 1, 2, or all 3 seeds germinate. So we take it one by one. Let's find the probability that all 3 seeds germinate first. That's 1 over 27. First one germinates, and second one germinates, and third one germinates. That will give you 1 over 27. Now, probability that only one of them germinates. That's what's it called? A bit different, but it's simple. If only one of them germinates, there are many possible ways that can happen. Either the first germinates, the second does not germinate, and the third does not germinate. Or the first does not germinate, the second one chosen germinates, the third one chosen too does not germinate. Or the first and second do not germinate, only the third one chosen germinates. So those are the different ways only one seed germinates. You understand? Those are the different ways it can happen that only one seed germinates. So we do 1 over 3 times 2 over 3 times 2 over 3, or 2 over, or this is or for addition, 2 over 3 times 1 over 3 times 2 over 3, or 2 over 3. First one does not germinate, 2 over 3. Second one too does not germinate, and 1 over 3. Third one germinates. So this gives you 4 over 27 plus 4 over 27 plus 4 over 27. That gives you 4 over 9. That's the probability that only one germinates. You keep that too. Now, our third case is that only 2 germinate. Only 2 germinate. There are many ways only 2 seeds can germinate. Either the first one germinates and second one germinates, but the third one does not germinate. Or the first one germinates, second does not, third one does germinate. Or first does not germinate and the last 2, second and third, germinate. So we compute the probability like this too, using our corresponding values, and we get 2 over 9. So now, probability that at least one germinates will now be probability that all 3 germinate, or what? 4 over 9 is representing probability that I think only one germinates. Yeah, all 3 germinate, or only one germinates, or what? Only 2 germinate. So we now add to get our answer, our probability of at least one germinate. Okay, question 10 now. Question 10 says 3 dice are thrown at once. Find the probability of getting a total score of 10. 3 dice are thrown at once. Find the probability of getting a total score of 10. There are many different ways of getting a total score of 10. Either you get 334, or you get 235, or 226, or what? Or 442, or 145, or 136. These are all the different outcomes from the 3 dice that can give you a total score of 10. Let's now take them one after the other. 334. This can also happen in many ways. If we label the dice die A, die B, die C, it's possible that die A gives 3, B gives 3, C gives 4. Or die A gives 3, B gives 4, C gives 3. Or on die A 4 shows up, on die B 3 shows up, and on die C 3 shows up. Those are the three different ways of getting 334. So from each die, probability of getting a 3 is 1 over 6. From die B to 1 over 6. Then probability of getting a 4, 1 over 6. So you compute that for each bracket, you get 1 over 72. That's the probability that you get a total score, you understand, from the results 3, 3, and 4. Let's now find the probability. Second one is 2, 3, and 5. Let's find the probability of getting a total score of 10 by getting 2, 3, and 5 from the 3 dice. So 2, 3, and 5 too can occur in many ways. Either 2 from die A, 3 from die B, 5 from die C. Or 2 from die A, 5 from die B, 3 from die C. Or 5 from A, 3 from die B, 2 from die C. Or 5, 2, 3 in that order. Or 3, 5, 2. Or 3 from die A, 2 from die B, and 5 from die C. So each of these is also 1 over 6 times 1 over 6 times 1 over 6. And there are 6 of such brackets. So you are going to have 6 different brackets. 1, 2, 3, 4, 5, 6. Each of them is 1 over 216. So if you add 1 over 216 6 times, you will get the same thing as 6 times 1 over 216, which is 1 over 36. Okay. Another way of getting a total score of 10 is to get 226 from the 3 dice. Now 226 we can get in different ways. Either 2 from die A, 2 from die B, and 6 from die C. Or 2 from die A, 6 from die C, 2 from die B. Or 6 from die A, 2 from die B, 2 from die C. And that's all. Either 226 or either 226 die ABC. Dice ABC, or 262 dice ABC, or 622 from dice ABC. Those are the different ways of getting a total score of 10. We discussed 226. So that's just 3 times 1 over 216. That gives you 1 over 72. I hope you know how we got this 1 over 216. Probability of each result is 1 over 6 times 1 over 6 times what? 1 over 6 times 1 over 6. So it will give you 1 over 216. If you multiply that by 3, because you have 3 of such brackets, you get 1 over 72. Next is the probability of getting a total score of 6 with a total score of 10, with the numbers 1, 4, 5 coming out of the 3 dice. Now there are 6 different ways of getting the results 1, 4, 5. Either you get 1, 4, 5, or you get what? 1, 5, 4, or you get what? 1, 4, 5, 1, 5, 4, or 4, 5, 1. You understand? 4, 5, 1, 4, 1, 5, or what? What's another possible way? 5, 1, 4, 5, 1, 4, and what? 5, 4, 1. I think I'm up to 6 now. 1, 2, 3, 4, 5, 6. So those are the 6 different ways of getting the result 1, 4, 5, or of getting a total score of 10 with the numbers 5, 4, and 1. So all of that too will lead to 6 times 1 over 216. You prepare your result, you keep it. 442 can happen in 3 ways. Either 442 or 424 or what? Or 244. That's the only way. Only 3 ways you can get a total score of 10 with the numbers 4, 4, and 2 from the dice. So 3 ways times 1 over 216 will give you 1 over. 3 ways times 1 over 216 will give you 1 over 72 also. Then 1, 3, and 6. These are 3 different numbers too. So this one too will lead to. This will also lead to 1 over 216 times 6, and that's 1 over 36. So now the probability of getting a total score of 10 from the 3 dice will now be the sum of all the different ways that can happen. It will be the sum of all these, 6 different ways that can happen. You add and simplify, you get your answer. These are the 6 different ways we have said that can happen. That can happen in all these 6 different ways. And we've computed their probabilities. So you just add and get your answer. A coin is tossed 3 times. Find the probability of getting 2 heads and a tail. 2 heads and 1 tail. Okay, a coin only has 2 outcomes possible, head or tail. Probability of getting a head is 1 over 2. Probability of getting a tail is also 1 over 2. So probability of getting 2 heads and 1 tail, if the coin is tossed 3 times, will be the probability of getting either head, and tail. That's head first time, head second time, tail second time, tail third time, or head first time, tail second time, head third time, or tail first time, head, second and third time. I could keep all this in brackets so it looks neater. So you compute their probabilities and add to get 3 over 8. Is that clear? Probability of getting a head first time is 1 over 2. Probability of getting a head second time is also 1 over 2. Probability of getting a tail the third time you toss the coin is still 1 over 2, because each of those events are independent. So we use multiplication sign to compute their probabilities. Or it could happen this way, or this way, or this way. You could get 2 heads and a tail in any of these 3 ways. You add and you get your answer. B says find the probability of getting at least 1 head. At least 1 head means 1 head or 2 heads or 3 heads. So we are not going to do this again. We have already found probability of getting 2 heads. So we keep that somewhere. Let's now calculate probability of getting 1 head. You could get 1 head in 3 ways too. Either head first time, tail second time, tail third time you toss the coin. Or tail first time you toss the coin, head second time, and tail third time you toss the coin. So, or you could get 1 head by getting a tail first time, a tail second time, and a head the last time you toss the coin. So those are the 3 different ways of getting 1 head in 3 tosses of a coin. So you compute your probabilities, you get 3 over 8. Probability of getting 2 heads, we did this previously, so no need to repeat it. Now let's find probability of getting 3 heads. There's only one way that can happen. You can get 3 heads only if you get a head first time, a head second time, and a head the third time. Can you see that? So that's 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 8. So probability of getting at least 1 head is now probability of getting 1 head or 2 heads or 3 heads. At least 1 head means 1 or 2 or 3, not 0. You understand? It's only 0 heads that will be excluded. So you add, get your answer. Number 12 is on cards. We don't know the contents will be given if we come across it in an exam. When children are born, if they are equally likely. When children are born, it says they are equally likely to be boys or girls. If they are equally likely to be boys or girls, it means probability of giving birth to a boy is 1 over 2. That of giving birth to a girl too is 1 over 2. Now, in a family of 4 children, we want to find the probability that there are 3 boys and 1 girl. Okay, there are many ways this could happen. We could have 3 boys and 1 girl if the first 3 children are boys and the last child is a girl. Or if the girl is the 3rd child, that means first 2 are boys, girl is 3rd child, and the last child is a boy. Or if the girl is in the 2nd position, the first and last 2 are boys. Or girl is first child, and the remaining 3 children are boys. So depending on the arrangement, so you compute your probabilities. Each one is 1 over 2, but they will be in different brackets for these different ways. Then you add, you get your answer. Probability of getting 3 boys and 1 girl is 1 over 4. Okay, probability that we want to find the probability that there are 2 boys and 2 girls. We also find the different arrangements of all these. 2 boys could be first 2 boys, then next 2 are girls, or any of these. I think that's 1, 2, 3, 4, 5, 6 different ways that can happen. There are 6 different ways that can happen. So you compute all the probabilities. I've actually represented them with, you understand, symbols here, just to show you that the brackets are just repeating. 1, 2, 3, 4, 5, 6. So that's 6 times 1 over 16. That gives you 3 over 8. Okay, 14 says in a bag there are 3 black, 4 white, and 5 red balls. Find the probability of picking. Okay, if 3 balls are picked at random. Without replacement, find the probability of picking 1 of each color. 1 of each color means black, white, or red, but the order may now be different. There are different ways that can happen. Probability of picking 1 of each color is the same as probability of picking black first, white next, red last, or black, red, white, or white first, black next, red last. Or picking a white first, a red next, and a black last. So we now compute all the different ways of getting that. Now the total number of balls is 3 plus 4 plus 5, 12. Excuse me. Probability that the 3 balls picked are 1 of each color is probability of picking. What's our first combination? Black, white, red. Probability of picking a black first is 3 over 12. If you don't replace that black you picked, there will be 11 left, 11 balls left. Probability of picking a white next is what? Going to be 4 over 11, because there are how many whites? 4 whites and 11 balls remaining. That's 4 over 11. Then probability of picking a red last will now be 5 over 10. Because after picking the first 2 balls, there's 10 balls left out of 12. So probability that the last ball picked is a white would be 5 over 10. So you do the same thing for each bracket. Probability in the second combination, in the second way, it's possible to pick 3 different colors by picking black first, red next, and white last. Probability of picking a black is, how many blacks do we have? 3. So that's 3 over 12. Probability of picking a red next is what? 5 over 11, because after picking the first black, there's 11 balls left, or there are 11 balls left. So probability that the second one is a red is 5 over 11. Now, after picking these first 2, you have 10 balls left. Probability that the last one is a white will now be 4 over 10. So you repeat that for each bracket till you get to the end. Then you get your answer. You add one after the other. You add the results of each bracket, then you get your answer. Probability of picking at least 2 red balls. Okay, to pick 2 red balls, at least 2 red balls means 2 or 3 red balls. At least 2 means not less than 2. We can say it like that, not less than 2. So if it's the probability of picking at least 2 red balls is the same as the probability of picking not less than 2 red balls. There are many different ways this can happen. You could pick 2 red balls or pick 3 red balls. You understand? In how many ways can you pick 2 red balls? There are many ways you can pick 2 red balls. Either you pick red and pick white last, or you pick red first, white next, and red last. Or you pick white first and pick red the next 2 times. Or the first time you pick, it's a red. Second time it's a red. Third time it's a black. Or first time it's a red. Second time you pick a black. Third time you pick a red. Or pick black first, then red and red. So each of these you compute separately. Let's go. You understand? Then this is now probability of picking 3 reds, which we will compute after finishing this first bracket. All of these represent the different ways of picking 2 reds. So you could pick 2 reds and 1 black, or 2 reds and 1 white. So then this now represents probability of picking 3 reds. So we have to add, because we are looking for probability of picking 2 reds or 3 reds. At least 2 reds will mean 2 reds or 3 reds. So we compute them separately, like this. We compute them separately like this to get our answer. I think I'm going to need to explain this one by one. Red, white. Red is 5, white is 4, and white is red is there are 5 reds and 4 whites. So probability that you pick a red first time is 5/12. Can you see that? Probability that you pick a red second time will now be 4/11. Because since there's no replacement, after the first pick, you will have 11 balls left. So probability that the second one too, we are treating this now. I hope you can see we are treating this case now. Probability that the second one is also a red will now be 4/11, because the red will decrease by 1 from 5 to 4, and the total number of balls will reduce by 1 from 12 to 11. So then the last case, or the last probability, is probability of, let me just take all this out. You can do it yourself. Probability of picking a white last. There are 4 whites, and now there will be 10 balls left. So that's that case. Now, this is another way of choosing 2 reds and 1 white. The white is in the middle. So red first, 5/12. White next, 4/11. There are 4 whites, and now there will be 11 balls if the first one was not replaced. Then red last. You have picked one of the reds, so it will reduce to 4. And now you have picked 2 balls. You have 10 left, 4/10. Okay. Third case is, this is the third case. Third way to pick 2 reds and 1 white. So that's white, red. Probability of picking a white first is what? 4/12, because there are 4 whites. Probability of picking a red next is 5/11. There are 5 reds, and now you have 11 balls left. Then probability of picking another red is also 4/10, because after picking the first red, you have 1 less red. The red will reduce to 4, and the number of balls left is 10 now, 4/10. So you do the same thing for all other possible ways of choosing 2 red balls. Then outside of it, or outside of the bracket, you now calculate the probability of choosing 3 red balls straight away. That's red. Red first time 5/12. That will reduce to 1, 4/11. The number of red reduces to 4. Number of balls altogether reduces to 11. So the probability that the second ball is a red is 4/11. And that's the probability that the third ball is also a red will now be 3/10, since there's no replacement. Is that clear? So take note. So you find the answer for each bracket, you add, you get 9/22. All right, a committee is to be formed from 6 men and 4 women. Okay, to form a subcommittee of 3. Okay, a subcommittee of what? Of 3 is to be formed from a bigger committee of 6 men and 4 women. The question says find the probability that all 3 are women. Okay, all 3 are women is straightforward. The first is a woman, second is a woman, third is a woman. First woman, the second one you choose is also a woman, the third one is a woman too. So in how many ways can that happen? In how many ways can that happen? Woman. That's 4/10 times 3/9 times 2/8. Don't forget, without replacement. The instruction is in the question that the selection is done without replacement. I think that's 15. A subcommittee is made by randomly choosing 3 of the committee members. What is the probability that they are all women? That's women. So that's what? Okay, I think. Okay, that should be correct. 1/30. Women. First one is a woman, 4/10. Altogether 6 plus 4 will give you what? 10. Second, that is the probability that the second one is a woman too will now be 3/9, because the number of women will reduce to 3. Total number of people in the committee will reduce to 9. The probability that you choose a woman next is now 3/9. Also, the probability that you choose a woman last is also 2/8. The number of women reduces to 2. Total number of people in the committee reduces to 8. So I think that ends that. B, probability that 2 of them are men. So that means you are looking for the probability that you choose 2 men first and 1 last woman, or the woman is chosen the second time as the second person, or you choose the woman first and the second and third persons you choose are men. These are the 3 possible ways of choosing 2 men and 1 woman, because 2 of them are men is the same thing as 2 men and what? 1 woman. So take note of this. Exactly. Is that clear, Sina? So you do the same thing. Each bracket, 6/10, 5/9. Let's clean all this so you can see the numbers well. 6/10, 5/9, 4/8. Or what? 6/10, 4/9, 5/8. Or 4/10. You understand? Here, the probability that the first person chosen is a man is 6/10. Now, the probability that the second person chosen is a woman is 4/9, because there are 4 women, but now the committee has 9 people left since there's no replacement. The probability that the third person chosen is a man is now 5/8, because you've chosen 1 man before here. You chose 1 man first, so the number of men reduces to 5, and the number of people in the committee now reduces to what? To 8. So that's another way you can choose 2 men and 1 woman. Or you can also choose 2 men and 1 woman by luckily choosing the woman first, and then 6/9, 5/8 for the next choices being men. So you add, you get your answer. Question 17. 10 marbles are in a box. I'm just forming the question of fun. You see it in your textbook. 10 marbles are in a box. 7 black and 3 reds. Is that clear? 7 blacks and 3 reds. If 3 marbles are chosen without replacement, find the probability that they are chosen in the order red, black, red. I'm sure that's the question. Let me confirm. Find the probability 1 red, 1 black, and 1 red marble in that order. So find the probability that they are chosen in the order red, black, red. Okay? Does it say without replacement or not? A box contains 10 marbles, 7 of which are black and 3 are red. 3 marbles are drawn one after the other without replacement. Find the probability that they are chosen in the order red, black, red. So first one is a red, will be 3 over what? 10. You understand? I should have done this somewhere. 3 plus 7 is 10. So the probability that the first is a red is 3 over 10. The probability that the second one is a black is what? 7 over 9. Because we still have 7 black balls there untouched. And the number of balls reduces to what? 9 after choosing the first one. Then probability that the third one is a red is 2 over 8 as well. Because the number of reds now becomes 2. Total number of boxes, marbles in the box becomes 8. So that's 7 over 120. Probability that there are 2 black marbles. 2 black marbles means either you choose black, black, red, or black, red, black in that order, or red, black, black. Those are the 3 different ways you can choose 2 black marbles. Because if you choose 2 black marbles, that means you chose 2 blacks and what? 1 red marble. Is that clear? Okay, the statement has just been shortened. So compute that yourself, add the different probabilities, get your total, get your sum, get your probability. Probability that at least 2 marbles, probability of choosing at least 2 black marbles. At least 2 means 2 black marbles or 3 black marbles. 2 or 3. Those are, interpretations you must understand. At least 2 means 2 or 3. Probability of choosing 2 black marbles. I think we found that already. 21 over 40. Did we do it again? That was a mistake. I shouldn't have done this again. 21 over 40. We already have it here in this question B. But no problem. So I ended up writing everything here again. Okay, no problem. So we should have only found probability of choosing 3 black marbles. We just bring this answer forward from question B. So 2 blacks, or 3 blacks. That's the meaning of at least 2 or 3. At least 2 means 2 or 3. We already did this in question B. So it is only this one that concerns us now. What's the probability of choosing 3 black marbles? That's black first. Let me clean all these steps. Yeah, we don't need this. Okay, at least 3 blacks means black first, black second time, black third time you choose. Black the first time, black the second time, black the third time. That's 7 over 10. First is black. Reduce that to 6 over 9. Second is also black. Then 5 over 8. The first time you choose, there'll be 7 blacks out of 10 balls altogether, or marbles altogether. Probability of choosing a black again is now 6 blacks left out of 9 marbles left. Probability of choosing another third black ball is what? There'll be 5 black balls left. There'll be 5 marbles, 5 black marbles left, and 8 marbles left altogether. So 5 over 8. You compute that, you get 7 over 24. Add your probabilities. This means 2. Probability of picking 2 or what? Or 3. Probability of picking 2 or 3. So that gives you your answer. 49 over 60. D says, find the probability of picking at most 2 black marbles. At most 2 means not more than 2. That's 0, 1, or 2. Exactly. Probability of choosing 0 black marble means choosing red all throughout. That's the probability of choosing red throughout. Red, red, red. So you compute that. 3 over 10 times 2 over 9. 3 over 10 times 2 over 9 times what? Times 1 over 8. 3 over 10, 3 red out of 10 first time. Second time you choose, there'll be 2 reds left out of 9. So probability of choosing a red marble second time is 2 over 9. The third time you choose, there'll be 1 red marble left out of 8. Probability of choosing a red marble is 1 over 8. That's 1 over 120 altogether. You keep that. Probability of choosing 1 black is 1 black marble can be chosen in any of these ways. Either black first, then red, red, or red, black, red, or what? Or this third one, I think we have made a mistake. Black, red, red, or red, black, red. Or red, red, black. Or red, red, black. That's the thing then. This should be or red, red, black. So you compute their probabilities. I'm not going to show you that. You understand it very well by now. 7 over 40. Then 2 blacks, 21 over. Probability of choosing 2 black. Let me just put probability here. Of choosing 2 black marbles is 20 what? 1 over 40. We did that earlier. So you now compute it. At most, probability of choosing at most 2 black marbles will be that of choosing 0 black marbles, 1 black marble, or 2 black marbles. So everything will give you 17 over 24. Question 16 is simple. It says 2 fair dice are thrown together at once. Find the probability that the sum of the outcome is at least 10. This one is simple. At least 10. This is the table of possible outcomes. Of the possible sums of the outcomes. This is the table of possible sums of the outcomes when 2 dice are thrown at once. So I've added the results. Okay, what's the probability that the total score is at least 10? All of these scores are at least 10. I think this will make it clear. At least 10 means 10 or more. So all these results are at least 10. How many are they? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So probability of getting a total that is at least 10 is 6 over 36. All of these outcomes are 36 in number. Look at that line. They are 36 in number. The outcomes are 36 in number here. So I don't want to go beyond the outcomes. Okay, they are 36 in number if you count them 6 times 6. So next is probability that the total score is at most 10. Okay, at most 10 means 10 or less. So that means 10 or less. This is the group of outcomes that are at most 10. 10 or less. There will be how many in number? There will be 33 in number. So that gives you 33 over 36. Probability that the total score is less than 3. Total score is less than 3. There's only one total score that's less than 3. So that's 1 over 36. Probability of getting a total score of 7. 7, how many total scores are 7? All are aligned in this axis. These are all the total scores of 7. 1, 2, 3. How many are they? 1, 2, 3, 4, 5, 6. So your probability there is 6 over 36. You always write this, very important. It's part of the required steps. E, find the probability of getting a total score that's at most 5. Now, total score at most 5. At most 5 means not more than 5. So we just mark them not more than 5. That's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probability of getting a total score that's at most 5 is what? NR over number of required outcomes over total number of possible outcomes. Number of required outcomes over total number of possible outcomes. 10 over 36 gives you 5 over 18. So we will take some exercises on probability. I'll send it to your mails. That ends the exercise.